Alright, time for another draftphysics.com, debatephysics.com, also video presentation. So, we will get to gravity, I'm doing these videos about the general subjects just to make it clear and to kind of take what I've done over the last 10, 15 years, whatever, and just the best of kind of thing. So I'm redesigning the website to make it more mobile friendly and all that kind of crap. And so the first video I did was on charge, which is basically the only function that the universe is really doing. That is the transition from force, stuff moving the speed of light, interacting with matter and causing it to move some lesser speed, electrons and protons specifically, and that they're held together by charge, and that creates this opportunity to create this side effect called gravity. Gravity is not really a force itself, it's just a consequence of the force interacting with matter. All the forces, all the things that we call a force that we think of as being distinct and different, magnetism, light, electricity, these are all the same thing. They're all being caused by the same basic interaction, which is described in that first video about charge and the simple 2 plus 2 plus 3 rules of interaction between the force and electrons and protons. Anyway, having said all that, so the gravity video, this video will fit right in here. And so I just go over these bullet points and explain that, they just gave up on a mechanical description of reality. Physics is about something else. It's not about anything physical. Okay, so there's no physics in the physics. It's all mysticism and voodoo. And the whole idea of, Einstein calling quantum mechanics entanglement spooky action when space-time is spooky. Space-time, I mean, it's not a physical function. It's, some bent geodesic thing happens. Stuff is given momentum. You have to concede. The whole idea that the Earth is moving into you and that you're not moving into the Earth is just so ridiculous. You're just saying, why do people fall for that kind of crap? It's just so bad. And then, so, it all comes down to the simple argument that it's a push averse, that pull is kind of a silly idea. It's really easy to bang something into something and move it. Really hard to just pull on it, with anything. You need to push to pull, frankly. And, and so wherever you see something that looks like a pull, it just means there's an absence of a countering push. And that's basically the function. So we'll do gravity. And see how it goes. See if I can persuade you that, come on, it's gravity. They basically concede that the function works at basically the speed of light, that gravity changes at the speed of light. So if the sun disappeared, it would take 8 minutes for us to be affected in terms of the gravitational change. So clearly, there's a huge reason to believe it has to be connected to these same forces that create magnetism and light, and that they're all bound by this speed limit, and that this is the fastest that things can happen in the universe from one place to another. And it just makes so much more sense to say, it's that simple. Now, Newton and others drew the conclusion, Newton sort of put it together, that the inverse square law has something to do with this, and that's basically the function of any object that produces an explosion, for example, anything that's spherical and produces an explosion or something, it would produce the inverse square law, is how you get hit by the stuff coming out of the thing. So a light bulb is obeying the inverse square law. So twice the distance, 4 times less photons hit you. So, the closer you get, twice as close, 4 times as much light hits you. So there's that quadratic relationship, and that just has to do with the fact that you're spreading something in 2 dimensions. So obviously, twice the distance, it's twice the spreading, and therefore 4 times less stuff. Now that's another huge giveaway. It's a basic function, so you're just saying, well, basically it's a light bulb in reverse. That somehow this external pressure goes into the earth, and somehow a little bit less comes out. And it's not too much of a reach to recognize that, yes, that's because stuff happens when force hits matter. It moves the matter, and the matter moves a lot slower. So I have used the analogy, and I think it's reasonably valid. You could think of it as like little Sisyphuses in the universe, okay? And when they're flying around free in the universe, they're going the speed of light. And when they're stuck to a piece of matter, pushing it, then they're going to go some much slower speed. So some velocity that will be less than, the speed of light. And just from that fact alone, you could kind of deduce that in these 2 universes, one where the Sisyphuses are pushing matter, and ones where the Sisyphuses aren't, that essentially force, if it had a history and it had a destination, a future, you could understand that if it's unencumbered by pushing matter, slowing down, that it's going to get to more places and do more things, which you could argue is the same as interactions. That's why as you pressurize something, as you make the container smaller, the pressure increases and the heat increases, is because you're causing more interactions. So when the force is moving slower, pushing matter, it's not going to have as many interactions, meaning there'll be less energy, essentially. So in a way, it's a it's a way of storing energy, frankly, because you've increased the mass. Okay, so you really haven't lost any of the energy. It's just now you have a small v and a bigger mass, where before you had a big V and a small mass, and all you've done is do a conversion. But those conversions are time-consuming and messy, and so you can't undo them instantaneously, and you can't do them instantaneously. And so that's why there's some difference. So the simple argument is that as soon as you put a bunch of matter together, what it really is a bunch of electrons and protons, and what you're basically doing is moving it a lot. So it's doing a lot of jiggling, as Richard Feynman would say. And that movement, isn't getting it somewhere. So it's just doing this kind of stuff. So there's no change, essentially, in the big picture of the universe. There's just a lot of this going on. And that's real energy. Just because it doesn't produce a distance doesn't mean it's not work or energy. And it is. And that's the difference. So the Earth, any collection of matter, where you're going to be moving the matter, jiggling it, heating it, essentially. And the Earth is very hot in the inside, indicating it's doing a lot of that. And something has to be fueling that, right? You could figure out that, well, if the Earth is molten on the inside, there really isn't anything to stop the heat from leaving. Heat likes to move from hot things to cold things. Space is very cold. no reason for the heat not to rush into it, so to speak. And so you have an object that's obviously got to be maintained at a temperature, so it's got to stay hot. Something has to keep fueling the 4,000 degrees that are inside the center of the Earth. And the point is that what's fueling it is gravity. So the force, okay, proton force, electron force, if you watch the EM video, charge video, goes into the Earth, okay, as a certain amount, and a little less, okay, comes out. And that's the simple argument, because it has to move a bunch of matter to get out, and moving the matter consumes its work function, its capacity to do work. And so more goes in than goes out at this exact moment. More is going into the Earth than it's coming out of the Earth, and therefore there's a differential, and that's gravity. And obviously it would be completely dependent on how many electrons and protons there are inside the object. That'll decide how much matter you're moving, how many electrons and protons, and how much is getting consumed. And so the heavier it is, the more dense it is, in terms of more how compact the electrons and protons are, the more gravity it will produce as a consequence of the consumption, okay, of an element of the force, in the sense that it's when it's moving matter, it's not getting as far as it would get if it wasn't moving matter. Alright, we'll see if we can rephrase some of this, and such. Be back in pretty soon. Alright, so I'll just redo it again, just restate it again. So you can understand, if there were bits of force, okay, and that's what I'm arguing, there are in the universe moving the speed of light, and when they're free they do this, and then if I put an electron in their way, okay, then they only do, this in the same amount of time. And you have this differential. And that's what is happening inside the Earth, is that every time a force bit interacts with a piece of matter, it changes its momentum. It either sticks or reflects. And it's going to create heat. And the heat requires energy, so it's the heat is essentially a symptom, okay, of the creation of gravity, and it's showing you the missing energy. It's showing you basically why there's less going out than went in, because you can see what's stuck in, which is the heat. So it's another way of understanding that that's what this differential represents, is how hot, did you make something? And we're talking about hot in the Kelvin scale. We're talking about everything that is, anytime matter's moving, it's absorbed a force. A force has stuck to it and is just pushing it. A Sisyphus has gone from flying around free to pushing an electron at 1/4 or 1/10 or who knows, some percentage of the original speed, diluted by the percentage of the force relative to the matter in terms of its mass. So I'd argue it's probably something like 10%, but that's just a wild guess, pretty much. And that if matter, an electron, can collect 10 bits of force, then maybe it can get close to the speed of light. But it can never get there, because it's always 10% added of the amount left over. So it's, you can never get to the speed of light, but it can get close, depending on how much energy it collects, pushing it in the same direction, bits of force. Alright. Yeah, it really is, it's very simple. So, and you can just sort of understand that as the matter pushes, right, what's happening is the gravity hits, okay, it pushes on an electron. Well, that electron pushes on the next electron, pushes on the next, pushes on the X. So it converts the force from a raw force, okay, into the momentum of the electron. You know there's a force between the electrons, okay, that's a pressure between them, and it just creates a higher pressure and a higher pressure and a higher pressure. So you go from having the raw force pushing when you get deeper and deeper into the earth to it all being converted into pressure between the electrons. So even though the gravity inside the center of the earth is net nothing, you know that, well, it's really not net nothing pressure. The pressure is incredibly high. So all of the gravitational force that started out here has now been converted into an equal amount of pressure. So even though there's no gravity, quote unquote, the consequence is that there's a gigantic pressure. So you know that the actual force of gravity is still moving the stuff exactly as you would expect. That is, it's pushing from the outside, and in the center there's a direct conflict between those two pushes. And so the full weight of all the electrons, the full weight of all the electrons above some point in the center is all pushing down, and they're all pushing down from the other side, and that's the real, it's just a demonstration that the gravity as a free force doesn't have to get to the center of the earth, because the pressure will get there, and the pressure is essentially made out of the same force, so it pretty much equals the same thing. You're just going to end up moving more matter, hitting more matter. It's getting more and more concentrated the deeper you go. So that's the other part of the whole buoyancy argument, is all the heavy stuff is in there and the light stuff is on the outside. And so that's another problem. Alright, so lots of related subjects, so I will make other videos because buoyancy is very interesting, and the very idea of you having enough buoyancy to cause stuff like hydrogen or helium to escape the earth is again a questionable theory. Yeah. So we'll go through the points, and I guess, I'll bring up the subject of drag now, because that's the only real argument against a particle theory of gravity. Alright, so in the Feynman lectures, Feynman goes over the subject of gravity, and he uses this, mock gravity, particle gravity, as an example of a failed theory. And, and the failure is basically this idea, okay, that if you had a field of force or an external universe full of energy, that the idea would be is that if something was moving, okay, had momentum in that field, so if I threw a wrench into space, the fact is the wrench would hit more force coming towards it, okay, than behind it, okay, even though it's moving the speed of light, which is a huge difference. So you're talking about something moving much slower. The object, the wrench, okay, is moving a lot slower than the speed of light, and so it's moving a lot slower than the force pushing it. But anyway, this idea is that yes, you would run into more force, and therefore whatever momentum you had would be reduced over that interaction, because there's more force pushing against your motion than aiding your motion, so you're no longer in a balance. So you couldn't maintain your MV because you're moving into the wind, so to speak. You're creating wind by moving. And so what would happen in an atmosphere, for example, if you shot something into the atmosphere, and if there's no wind, you're obviously hitting more stuff okay, in the direction you're going, then you're hitting in the opposite direction, which is 0. So you're definitely going to slow down. Your energy is going to be absorbed as friction. So essentially it's a friction argument. Now, the counter argument that Feynman was already aware of, frankly, I mean, certainly should have been, is that electrons and protons, okay, the elemental bits of matter, do show drag. Fact is, you can't shoot a proton to the surface of the moon or an electron to the surface of the moon. You can't use them as communication mechanisms because they have no durability. You can't get them to go very far, unless you keep supplying energy. So like in a linear accelerator, they have to keep pushing to get the electron to stay at a high speed. And in the same sense, all the other circular ones do the same thing. They have to keep forcing the electron over a differential of charge to keep pushing it. So they have to keep giving it a boost. Otherwise it runs out of momentum. So that's sort of a giveaway that, well, yeah, drag is a real thing, and there's some reason why things like helium nuclei, okay, can survive, drag. And so I could sort of draw an idea of a helium nucleus would be something like, all right, you'd have 2 electrons, and then you'd have 4 protons that in some way are, and this is because neutrons are protons, frankly, proton and an electron. So 2 neutrons would be 2 electrons, and then the 2 extra protons, making the helium nucleus. So it's a complicated object. I'd say the geometry is kind of simple. So if I could turn this, it would be like the protons are all in line, okay, and the 2 electrons would obviously be as far apart as they could be. And you could argue that one of the electrons is connected to these 2 protons, and the other electron is connected to these 2, kind of idea. And so that object you can throw through space. So that object gets here as cosmic rays, okay? It collides with the bits in the atmosphere and creates all kinds of scattered bits of stuff. They give them names, muons and taus and all kinds of other weird names. But they're probably just electrons and protons moving at different speeds. And if it moves at a certain speed, they call it something else. So if a proton's going very fast, they call it an anti-proton or a positron, an anti-electron. Yeah. But anyway, it's probably just a proton moving fast, or it's an electron moving slow, or whatever. Or a pair of them even, because you could break them off. And so again, it's kind of you really do have to understand the charge argument and the fact that there's every likelihood that you're going to create these kind of objects, that will have some capacity to retain their condition moving, given velocity when atoms degrade, like this deuteron, for example, 2 protons and an electron. You can understand why that would be, just by Maxwell's argument of what a charge is, why that would be a feasible mechanism, where the protons can't see each other, they are attracted to the electron. And the simple argument is this is what gravity's creating. The pressure that gravity creates the opportunity for these kind of objects to be made. And once made, if you were to disturb this electron and kick it out of here, you'd end up with 2 protons very close to each other, and there would be an intense amount of force created shooting them off at very high velocities. And so all of that makes sense. So in a sense, gravity is the great anti-entropy mechanism. That's in the text part. So anyway, so this object, you could understand that it might change its shape. So as it's moving, in a direction this way, it's getting, as a practical matter, it's interacting with less force from the sides because of that velocity. And so it would be starting to expand in one direction while it's being compressed in the opposite direction. And that expansion combined with that compression might equalize each other and enable it to maintain its direction, its forward motion. And there's other ways to explain something like that. Like I could make a box and I could throw energy into it, and the box would move, and then the box would stop when the energy hit the back, and then the box would move again because the energy's stuck in the box, and there's always a forward motion. So there's lots of ways of explaining how the motion is conserved, even in the presence of an opposing force, because of some element that equalizes the circumstance that perpetuates it, and then you can overcome the drag. But like I said, I don't have I can't give you the specific argument yet because I don't have it yet. But I'm sure it has something to do with this shape. And the fact is that it changes with velocity, and changing the shape matters in terms of how the energy is transitioned between the electrons and protons. And so, but the simple truth is that we know those things do fly through space, and we know these things don't. So you can't, the sun's not producing any electrons heading right for us, or any protons heading right for us. The only time it can emit an electron or proton is to create, some sort of gas, some sort of hot gas, some plasma. And then that plasma could shoot electrons and protons a short distance, but that's the only way technically you can have it happen. So, like I said, the simple truth is that on the most elemental universe, again, the argument is that the real universe, the only one that really exists, just has electrons and protons in it, and just has these little bits of force in it. Proton force and electron force, and that's all that the real universe is doing. Everything else is some perversion of perception. So we can't see electrons and protons, so we can't see the real universe. So we see this stuff, which is electrons reflecting light. We see the outside of atoms, pretty much. We see, energy reflected, but we can't see, what actually reflected it. So, in a sense, it's smoke and mirrors from our weak perspective, and that the real universe really is just this stuff. There's such an insane density of that stuff. I mean, we got 100 billion cells in our brain. The number of electrons and protons is, times 10 to the 15 or some huge number. So it's just gigantic, the scale, the complexity. If you actually could see the electrons and protons, that our complexity is so dense and so thick, it's just beyond our capacity to even imagine it. But that universe is where everything happens first, and it's just operating on those 2 + 2 + 3 principles: 2 kinds of force, 2 kinds of matter, and 3 kinds of interaction, or an absorption. Sisyphus sticks, Sisyphus is liberated, or Sisyphus goes in and comes out with a different color shirt on. And that's it. And I would argue that those 3 simple rules do explain what we see. Alright, so I'll go over these bullet points kind of things. Okay, so first, there is no spooky space-time. So I'd say Isaac Newton sort of proved he made an argument against this called the bucket experiment, where you spin a bucket of water and demonstrated is the fact that the water rises up the side of the bucket. And relativity would argue that you can't tell which is actually moving. Did the entire universe spin, or is the buckets, the water spinning? And the simple argument Newton's making is that no, it's the water, because spinning the external universe wouldn't create a force. It wouldn't create gravity or something. It wouldn't move the water. The only thing moving the water is the momentum of the water, and the water's trying to go in a straight line. It can't do it, so it goes up the side of the bucket. And so that's the only explanation, is that the water really is moving. Now, I'd say that argument was never defeated by any kind of reasoning or logic, and it's a perfectly valid thing to understand that they're really spinning the universe would not make the water go up the sides of the bucket. Now, he also demonstrated that with a simple governor, where you spin a rod that has two weights on it, and the weights will lift up as you're spinning, and sort of proving that anything spinning, you really can't argue that it isn't obviously something you've given more energy to. So no matter what its relative condition, yes, we're both flying through space in some direction, the spinning object obviously has more energy. So whatever it has, whatever you're sharing, so I'm sitting here with the little spinning thing, we might be sharing a direction, but the stuff spinning actually has more energy. So anyway, it's a pretty good argument. So it kind of defeats relativity, in my opinion, and we don't really have to play with any idea that there's some new mechanism out there, some bent space thing, whatever the hell that would be, space-time thing, which is even more ridiculous, that you can never do anything to time. There's only 3 physical dimensions: forward, back, up, down, left, right. They create 90-degree angles to each other. That's all there is room for. So the word dimension is now complete, because nothing else fits the definition. There can't be a 4th dimension. You can call it something else, but it can't be a dimension. And whatever. Time is just a function. It just has to do with the fact that instantaneous speed isn't a thing. Nothing moves at instantaneous speed. So therefore, we have a slow-averse. It's a push-averse and a slow-averse. Even though the speed of light seems really fast, it's really slow compared to instantaneous. All right, anyway. You're being pushed into the earth, not pulled. So the push-pull argument's so obvious. I remember this one as being a challenge as a kid. Somebody'd goof on you, and the whole idea was they'd say, go pull on a doorknob, and then they'd show you, well, you really just pushed on the back of the knob, didn't you? You didn't really pull anything, you pushed on something. And so the fact is that all things we call pulls can be understood as inverted pushes. And in the case of force or other things, you could understand that if I have 2 competing forces and it's imbalance, I don't create something called pull by eliminating the force pushing this way. So if I have a force this way and a force this way and it's stuck, yin-yanging, I don't create pull by taking away a push. Now I still have push. And that's all there is push. We are pushed into the earth. It's just, it's the truth. Anyway, the cause is real things doing real stuff. So this idea of a bent geodesic, that somehow things are moving towards each other, but none of them have any real momentum. I mean, it's all kind of just nonsensical mush. This creating space, eliminating space, poofing it in, poofing it out, causing distance without any need for an energetic force. It's all really pointless. And it just takes gravity out of the equation. It's completely incompatible with their quantum mechanics, but it should be, because quantum mechanics is garbage. But anyway, the idea is it is a real force, like all the other forces that make things happen. It's just as real as light and magnetism. It's a real mechanism. It's not some bent thing. It's not some separate kind of physics. The elemental universe isn't more complicated. It's simpler, and it's just really bad science, frankly. The invention of this non-answer. You say, oh, Einstein solved gravity. He didn't solve anything. He didn't provide a better answer than Newton. He's just saying, well, here's a way to do the inverse square law. Well, I don't need a way to do it. I mean, I need a physical mechanism. Understanding that there is an inverse square law doesn't tell me anything. Telling me you have a magical mechanism that causes it, that doesn't explain anything. All right. Energy in, less energy out. So the simple principle is that's all gravity is demonstrating. And the real catch is the thing you have to explain isn't the pulling force of gravity, and I'm arguing it's obviously just a pushing force. The real catch is explaining magnetism and charge, where you not only have a pull, but you have a push. So you have the electrons repelling each other, and then the electron and the proton attracting. And that's the real cause. And gravity is just kind of a one-dimensional manifestation of that two-dimensional function, you could argue. So it's not... there is no force of gravity for electrons and protons. They're charged. And the function of charge is what's absorbing energy out of the field. And the absorption, the electrons and protons moving, is what is creating the deficit in the field energy. All right, as it goes through a material object, the field energy is degraded a little bit, and that's the manifestation of gravity. All right. So just another manifestation of the speed of light force. So there's a speed of light force. Everything's under pressure, constantly being pushed. Okay, and obviously it's going to tend to get spherical because that pressure is going to be pretty much even, generally speaking. And, it's just the exact opposite of a light bulb. It's the inverse square law in reverse. And you're basically just saying it's an implosion, and the implosion is being created by the fact that every time a piece of matter moves, a piece of matter over here has less resistance to its motion. There's less push. So the force is pushing, it pushes into matter. Matter absorbs some of the pressure, and now there's less pressure affecting the other object, so it moves into that less pressure. And they just keep doing that to each other. So the matter here is creating less pressure for the matter over here. And when this matter moves, there's less pressure against this one, and they just keep doing that. All right. Just the reverse of photons leaving a light. So that's just the inverse square law. That's the bent fabric kind of thing. Okay. It's not miraculous. And again, it's not about some underlying mechanism. It's about the simple fact that all I have to do is pressurize the universe and I'll create this effect. I mean, if you did this, if you actually did it with ball bearings, BBs, you could make a box that's perfectly elastic, perfectly springy, so the BBs never lose their velocity. I mean, move around inside of a box, and then you throw two things in that box that get hit by the BBs. The two things will move into each other. It will happen. This shadowing effect of Lesage gravity in principle works. The point is to describe why there's a shadow. And there's a shadow because the force is stored when it moves matter. Okay. Let's see. Gravity is the anti-entropy force phenomenon. So they always talk about entropy and how energy always degrades, and that somehow the whole universe is degrading into some sort of heat or unusable energy, when clearly gravity is doing exactly the opposite of entropy. It's taking chaotic, scattered matter and it's condensing it dramatically under very high pressure. And so it's just such an obvious anti-entropy force, in the sense that it's not a force, it's just an anti-entropy phenomenon. Yeah, force, phenomenon, event, function, byproduct. All right, the real force is charged bits of energy moving electrons and protons, thereby consuming a portion of the field's energy. So the fact is there's a bunch of this loose free sificuses. They get caught up pushing matter. They can't get where they were going. So there's a deficit in the pressure. So I can't have equal pressure if this pressure can't get here, because it's pushing matter. Simple enough argument. So I think I'll leave it there as the simple enough argument and such. So, yeah, I'll probably be replacing this video in the future with something maybe better, but we'll see how all that goes. But it is viable. Particle gravity does work, and frankly, all the physics ties together. I mean, it really is a physical universe made of real stuff doing real things, or real things doing real stuff. Yeah, as I put it. And you don't need voodoo explanations. You don't need this complicated functions. None of that's necessary. It's just momentum. It's just mass and velocity. That's the definition of energy. The little discrete sificuses have a mass, and they're moving a velocity. When they share their velocity, that is when they connect to a piece of matter, they increase their mass, and so they obviously move a slower velocity. And so all the energy is ultimately conserved, but clearly when things happen, changes. When sificuses are pushing boulders. Alright, so I think that's enough for this video. So in a little while I'll post the new website. It's not public yet. And then it'll be simpler and more easily navigated on mobile devices, one would hope. Anyway, so till the next time, and such and so forth and whatnot. Energy looks like the next subject.